So we see the problem specific. First handout was it's basically the in array, the midpoint gonna shifted, so that's what happened. So if we do standard case on how a binary search does is that we put items L and R on the edge cases per se, and then we plant the mid value per se. So I think the question that we do ask at this point is that it's like if my M, so there's like two conditions. It's either you fall under the graph that is on the Z side or the Y side. So the Z side is usually the one, so because in total you have like a normal graph, right? So this is the normal case, so I term this as X, right? And then the X will be transformed into cut into a Z and the Y graph. So in normal case, ascending will be just like this, but this time round the question specific is that it gonna cut somewhere, but you don't know where. So you leave with like a normal graph, which I call it the Z, and then you have the Y that is gonna cut somewhere, the abnormal graph lah. So Z, so I will put the Z actually to be here instead, because I'm more used to it. So I call Z actually the abnormal one, because it cannot cut somewhere. But Y I will call it the normal one, which is continuous from somewhere, right? So this is Y, this is Z. And then now back to our operation over here. So our question is gonna ask that if it's our because in normal situation, if say our M over here, right, our L over here, our M is usually more than our L. That's for normal case scenario, right? So we come back to here, we come back to the operation of a L, operation L. So if my M is more than L, so what I'm trying to check is that do I fall under the category of the Y or the Z? So for this question specific, it's more than L, and so I find it it's actually normal lah. So when it's normal, I fall it under the category of like a Y per se, right? But if it go to a side on the flip side of things, I'll say that it's the other graph lah. So for this case, it's the Y graph, right? So good. So now I do check that is both my L, okay, let me think. So I asked the question, L and M, which one So I do know that right now I'm on the y graph, right? So I check the y graph the minimum value first. So because I know that the graph gonna split into two, both the y and the z. So my objective here is very simple. I just want to check the minimum for each of the graph, right? So I want to check the minimum of each graph. So I take this value, I account for it, so I record it because I know that over here, which one is this value in y graph is basically at over here, which is at the L place. Then I done with my job over here already, so I cross out over here. I recorded this value, I put inside the result, come over to here. First thing first, I do account for the m value also before anything else at the very start, and then I account for the 3, and then I'm done my job here. I now want to go on to, I'm not interested in y graph anymore. I want to interest in the next graph, the z graph. So I shift both my L and the M to be over here right now. So this time around I take the L value once again, and this is 1, and I compare the 5, 3 and the 1, and obviously 1 is like the lowest, so I take 1 as like my sort of result. So that's how I choose for question specific operation, how I run everything. So if you were to actually figure is that question specific, it does ask us for the before condition, which is that everything is in order. So when everything is order, straight away you can think of the spell of using the binary search, which contains the manipulation of the L, M, and the R technique. Yeah, so the special rule is just that they actually cut it into halfway, so you need to spend the extra effort to actually dissect. So you split them into smaller problem. So we look at the x operation, we know how a normal graph look like, and for question specific, it actually split the graph into y and z. And then now it's just about like go back to your in array of the question specific and ask okay, you planted M, right? So you ask a question to determine whether you fall under the category of like y or z. So yeah, back to the operation specific things that it's gonna operate at. And then like every other question, you're gonna ask that brute force, like why not brute force one by one check. So binary search always has a counter argument of saying that I'm faster than you. It's because brute force is a big O of n, whereas binary search is always a log n time operation, big O log n. So yeah, that's all for this question. Everything comes to an end.